Started. All right. Good afternoon, everybody. Thank you so much for joining us today. For those of you who are not aware, we are going to be discussing the new flood and inundation mapping services that the National Weather Service is unveiling. There's a lot that's going to go into this, so hopefully just you can bear with me. If you have questions, we can certainly take them. But without further ado, I will jump right on in. So today's topics, we're going to review the National Weather Service's flood services that we already are providing and how these services would be added into the suite of what we're able to provide. We're going to do an application of these flood and inundation mapping services, as well as do a demo of how you can view these in your own operational setting, and then take any questions you may have. But again, if you do have questions in the middle of this, please do not hesitate to unmute yourself or put them in the chat. So what I wanted to make sure I started this off with is that nothing is changing to what we were already producing. So we're still going to be putting out our watches, our warnings, our advisories. We are still going to be sticking to the same, flash flood paradigm, riverine flooding, and coastal flooding. All we're doing is we're adding a service to the riverine flood services that we provide. So you're used to seeing hydrographs like the one up here on the right-hand side. And if you're used to seeing those hydrographs, you're used to being able to scroll down and seeing all of the impact statements that we have tied to those hydrographs. And those basically kind of walk you through kind of what are some of the impacts that you might see at specific levels. But if you've ever had to try to communicate flood impacts based off of a hydrograph or based off of these impact statements, you know that there's a gap here in the service that we can provide, that this is not all inclusive. So by adding flood inundation mapping services, we're changing the way we communicate river flood impacts. And I make sure I caveat that this is just for riverine flooding at this time. So we're basically putting water on a map. And a picture really is worth 1,000 words. I know you can all agree with that. So we're able to actually fill in the gaps. Instead of being able to provide a forecast at one specific location and some of the impacts just right along that gauge location, we're actually able to provide more actionable information, potential flood impacts further upstream and downstream of that gauge location in a much larger reach of the river. Now you're probably thinking, that's great, Katie, but you only have like 60-something river forecast points across Southeast Texas. What about the rest of the rivers and the creeks and the bayous? How are we going to manage all of that? Well, the beauty of taking all of these forecast points and this new service is that we are able to actually provide flood inundation mapping services to the majority of the rivers and creeks and bayous in our area. And I bet you're probably like, well, what do you mean? So we're going to be providing continental scale flood inundation mapping services across the country. So if you were to actually zoom into this area in basically the Kentucky area, you would see the high resolution availability of these flood extent maps that are going to be available. Now, these are not going to be available everywhere right off the bat. We are doing a slow implementation rollout, and I'll talk about that a little bit later. But this is a massive endeavor, and this is really transforming our hydrologic prediction capabilities. And you're probably like, okay, great. Well, how are you doing that? And that's a great question. So right now, we have 3,600 river forecast center forecast points across the country. Those are all of those dots on the left-hand side here, all right? That's one forecast point for every 1,000 river miles. The National Water Center has the National Water Model, which is now allowing us to enhance our hydrologic prediction services to basically 2.7 million reaches across the country, or 3.4 million river miles. Now, for those of you who are not familiar, the National Water Center is equivalent to the National Hurricane Center or the Weather Prediction Center or the Storm Prediction Center. They're just a little bit relatively new, basically established in the early 2010, 2012 timeframe. So the National Water Model is a hydrologic model framework that's simulating observed and forecast stream flows over the entire continental United States. So this is revolutionizing our hydrologic guidance, and it's allowing us to provide first-time coverage and service to many portions across the country. So this is great news, but you can imagine there's probably going to be some growing pains with this. So we're extending those river forecast center points. And what we're doing, one of the things I kind of wanted to take a step back with, is we're producing many different products from multiple runs of this national water model. And it's going to be a lot for people to kind of take in as we evolve and share these services. But the main service that I want you to take away is the inundation mapping service that's going to come from this, because this is ultimately going to be the bread and butter of the output from this model that you would use for communicating flood impacts. So I want you to think, like we have various weather models, we have various water models, and there's different forcing mechanisms. So in this case, we have 4 different runs of the national water model that will allow us to refine the hydrologic forecast across varying timescales. The first one is an analysis run. This is basically using a look back period of 3 to 28 hours. And it's basically telling you, where do we currently have flooding? It's using observed gauge observations and analysis to basically depict where is flooding happening. There's a short range run, which is being driven by the HER, and it goes out 18 hours. This is a great tool for us trying to pinpoint those rapidly rising, fast responding basins in the short time frame, potentially some flash flooding, but only on the riverine side of things. The medium range is based off of the GFS. However, we have come to learn, or we knew from the beginning, if you would have asked a meteorologist who is also a hydrologist, that the GFS probably wasn't the best model to pick. It was the easiest one for them to pick to prove this service was possible. But we basically took that service and replaced the meteorological inputs with the parameters from the national blend of models. So we actually have 2 medium range runs that are running simultaneously, and one is based off of the GFS and one is based off of the national blend of models. I'm sure you can guess which one is performing better most of the time. However, the GFS is the one that's going to be publicly available starting off right out of the gate. I want to make sure I caveat that, but that will change in the near future. The last run is the long range ensemble run, and this is the one where it basically gives you 30 days of data, and this is to help with water supply forecasting and long-term planning purposes. Okay, so for you, the biggest ones that you're probably going to want to pay attention to are the analysis, short range, and medium range, as well as the inundation maps that are going to come from those. Now, for those of you who don't know, a flood inundation map is a great tool that allows us to visualize these flood forecasts and better communicate flood impacts. But there are a lot of different uses for it, and we're going to talk about the application of these flood inundation maps in just a little bit. But before we do that, I want to make sure we kind of cover a baseline overview of these flood inundation map services so that you can have a better understanding and have better expectations of what these are going to provide to you. So we're going to cover some basic terminology first. The first terms that I want you to understand is the difference between a flood inundation map and a flood extent map. So a flood inundation map on the left-hand side is a map showing the spatial extent and depth of flooding for a specific water level or water level intervals at a individual stream, river, or bayou. A flood extent map is a map that is only showing the spatial extent of the flooding at that specific water level or interval. This is extremely important because even though you might be looking at a flood extent map and you don't have depth, that doesn't mean it's not a useful tool. You just have to be careful with how you use it. You don't want to try to estimate the depth when you could be over or underrepresenting the depth, since it's not supposed to be used that way. You can also be deceived by a map if it has multiple colors or multiple shadings of a color where you think that it might show depth, but in reality, it just has multiple flood extents overlaid on top. So you have to be careful that you are making sure that what you're looking at is either an inundation map or an extent map. And a lot of times people will use the terms interchangeably, which you probably already caught me doing it, where I refer to a flood extent map as a flood inundation map. That's okay. It's just making sure you know the details behind the map that you're looking at. The next terms that we need to make sure you understand are the difference between a static map and a dynamic map. So a static map, the one on the left-hand side, is a library of maps that are pre-made for certain levels to be accessed at any time. So these libraries will typically have levels or categories that you can choose from, whether that's minor, moderate, major river levels, or every foot in between. But they're basically available year-round, and they're used for pre-planning, pre-positioning resources, tabletop exercises, things that you would use in the preparedness phase. Dynamic maps, like the one you're seeing on the right-hand side, are generated during an event, and they're using current conditions, possibly using forecast conditions. These libraries, I refer to them as libraries because sometimes they are libraries, are associated with dates and times, and they are only available during the actual event. So an example of a dynamic flood map would be the Harris County Flood Control District maps that are on their flood warning system. Those are dynamic maps that are run in real time. They are based off of current observations, but not forecast data. The one here on the right-hand side is an example coming from the Army Corps of Engineers. These are based off of dynamic maps run real time and typically in tropical systems, where it's using forecasted rainfall from the National Weather Service, but it might be outdated by 6 to 12 hours, which can make a big difference in 6 to 12 hours if that forecast changes. So you have to be extremely careful using dynamic flood maps because of the timestamps and the inputs that are used. The last set of terms that I want you to be familiar with are high quality modeling maps versus efficient modeling maps. So what does this mean? All right, this is where you're going to put your hydrologic hat on here, your hydrologist hat. High quality modeling is basically engineering scaled models and maps, okay? These are high quality, meaning they have a lot of QA, QC that goes into it. Bridges and elevated surfaces and levees are all accounted for, but they are only available at select locations and usually centered around a river gauge. They are very expensive to create and maintain, so you typically don't see many of them available. Now, the efficient modeling maps are more widespread. They are a little less accurate because they're using more assumptions, or they're not using as strenuous of a QA/QC process to account for, say, elevated roads or bridges. They may or may not account for levees. It really just depends. But they're making assumptions so that they can run more efficiently and be more widely available. Just because you only have an efficient modeling map available to you and not a high quality map doesn't mean that you don't have a good map in front of you. It just means that you might need to use a little conservative approach with pulling out flood impacts for it, or maybe you don't have as much confidence in the output. It's just an all in how you apply the flood inundation map in your operations. So now what flood inundation mapping capabilities do we currently have, or the ones that we're going to be providing? So flood inundation mapping is not new to the National Weather Service. We're just expanding our service of flood inundation maps. So right now, if you were to go to the National Weather Service's AHEPS page, you would see that the National Weather Service has these AHEPS flood inundation map libraries. These are static maps at roughly 200 river forecast center points across the country. Remember, we have 3,600 across the country just in general, but 200 forecast points that have these static maps. And these are derived from high quality modeling methods. So these are those engineering hydraulic based flood inundation maps. They're very good for planning purposes, and they are the best flood inundation map available, okay? But if you look on like basic what we have for Texas, you can see we only have 33 locations with these AHAPS maps, these static maps, and only 8 in the Houston area. And if you were to click on one of them, you can see that there's a upper and a lower bound. That is basically the extent of where the map is available. That's roughly only 1 to 2 miles upstream and 1 to 2 miles downstream. So in essence, you're only getting really good service at a small portion of the reach. And that's why we're expanding this service, even if we're using efficient modeling, so that we can have at least a map to kind of help point us in the right direction of what are some potential impacts. So this is what we currently have. This is what we're adding. So the National Water Model is producing 3 separate inundation maps that are publicly available for our area. The first one is tied to the River Forecast Center's forecast. All right. So basically, it is a dynamic flood extent map that is downstream of the River Forecast Center locations. These are derived from the RFC's forecast. So those are the inputs. So the rainfall that goes into the hydrograph, as well as the discharge that's coming out of it. And it's using the efficient modeling and mapping components of the National Water Model. This has a coverage of roughly about 100,000 river miles across the country. The second flood extent map that's going to be available, or that is available to us now, is the National Water Model Flood Extent Map. This is a dynamic map that is using the output from the National Water Model. So instead of the river forecast output, it's using the National Water Model's forecast and deriving a flood extent map with the efficient modeling and mapping components. So again, this is the one that's being driven off of the GFS. The last one is an analysis and a simulation flood extent map, where this is basically taking observed rainfall and observed stream data, and it's showing you where we currently have flooding expected or forecast. And again, these are all dynamic maps, which means they're run in near real time, and they're based on current and forecast conditions. These are really good for event-specific planning and response, and they can be used in conjunction with those static AHAPS FIMs that I just showed you. It's just a matter of what time frame are you looking at, what situation are you in, kind of a whole bunch of other components here. But all of these additions increase the availability of flood extent maps in our region, which is really good news. Okay. Now, where you would have a better map, that is where you would use the better map. So if you have a AHAPS map in the same area where you have the National Water Model flood extent map, you're going to use the AHAPS map because it's a better map. All right, so I've told you all of the great things, and these became publicly available on October 1st. I have to bring us down to earth a little bit because this all sounds great and wonderful that we've got flood extent maps across our area, but there are limitations that I want to make sure you're aware of so that you don't just blindly use these flood maps and start communicating flood impacts from these maps. So the first limitation of the National Water Model flood extent maps is that they're extent only. That's a given, okay? And that's probably the number one question we get from partners or from the public is, how deep is the water? Or, can I get a high water vehicle into this area, or do I need a boat? Well, unfortunately, with a flood extent map, you're not really going to be able to effectively answer those questions. But you still can be able to help them decide, is an area going to be cut off? Or do I need to make sure I have more resources in this area? Or do I need to make sure that, we're taking the necessary precautions for flooding in those areas? The second limitation here, excuse me, is that we're limited to a 10-meter digital elevation model. So this means that we can't see small physical features such as culverts or potential smaller levees that are not a part of the official national levee database. Okay. So there are going to be cases where the 10-meter digital elevation model might overestimate or underestimate flooding because it's not considering those local features like culverts. So those are things that we'll have to keep in mind. This is also using simplified physics. So basically thinking in terms of a scientist here, we're describing flood impacts that are based off of a more simpler approach to these modeling and mapping components. So there's more assumptions as you would basically in comparison to like a HEC-RAS or a hydraulic engineering model. Just using with a little less confidence. The national water model versions of these flood extent maps are limited by the QPF input. So right now, the national water model flood extent map would be limited to the GFS run. When we do move to the national blended models, I will certainly let you know that that change has happened. But that is one of the caveats. There are also no human influence. So basically no human hydrologist or forecasters are going in and mucking with the forecast to basically fix any issues that are happening on the fly, okay? Now the RFC flood extent map is based off of a human's forecast, but the national water model versions are not. There is coastal use, but it is limited. There's a coastal emission zone, and I'll show you what that looks like in a little bit. Basically, it's trying to make sure people understand that in the coastal community, there are additional assumptions that are not accounted for by using these simplified physics. So like total water level or basically your tidal influence. Or the lack of terrain and the 10-meter digital elevation makes the output in the coastal region even less a little bit less quality, basically. So you just have to be careful in the coastal emission zone. Doesn't mean they're not useful, just means that you have to be even more careful. There is a total water level forecast that is going to come out of the national water model within the next year or two that is going to account for tides and surge that's coming from the National Hurricane Center that is currently being tested and vetted across the hydrologist and the weather service. So that's something to look forward to. We're just not there yet. Lastly, so this bullet here, many bridges are not currently factored out in these maps. Levees are. So if anything's in the National Levee Dam database, they are accounted for in these outputs. But the bridges are not. So you might have an elevated bridge, such as like 99. The flood extent map might show that as being flooded, but it's an elevated surface. It's going to take a heck of a lot of water to cause 99 to go underwater. So you have to be careful with elevated surfaces, but that's why you have the National Weather Service to kind of help you with better interpreting these maps and the potential impacts. And that will be something we'll talk about in just a minute. I did get this question in one of our last trainings with the emergency managers, and that was the update times and when can you expect to get an updated flood map. So for the analysis and a simulation FIM, that's what's currently being flooded. This is updated roughly every 50 minutes. The National Water Model 5-day FIM, which is the one that's based off of the GFS, is updated every 6.5 hours. And the RFC 5-day FIM is updated every 45 minutes after a new River Forecast Center forecast shows up. So for example, the River Forecast Center will issue their official forecast in the morning time frame, usually around 7:30, 8 a.m. And it would take 45 minutes for the maps to run and be published on our service. If the RFC has to do an update to that river forecast, it will take 45 minutes for the new map to show up. The RFC typically does updates every 6 hours, so you should see an updated flood extent map every 6 hours, but you could see them in intermediate timeframes if they have to do an updated forecast. So I kind of alluded to this already, where if you have a better map available in an area, that's the one you should use. And that includes non-National Weather Service FIMs that are out there. So that includes Harris County Flood Control District's flood inundation maps, or the Army Corps of Engineers, or Fort Bend County Drainage District. If we deem those maps are better and they match the message of what we're trying to convey, those are the maps we're going to use. We don't have to use the National Weather Service maps. They're just there as a tool in the toolbox. So think about it as the inverse pyramid. You want to make sure, okay, you've got widespread availability. But where you have a better map, that's the one you're going to use. And that might be the RFC FIM. But if you have a detailed AHAPS FIM, where you have that RFC FIM, that's the one you're going to use. If you have a Harris County Flood Control District inundation map that's just showing the current flooding, and that's better than the GFS that's showing, crazy flooding across Harris County, yeah, you're probably going to use the Harris County Flood Control District maps. This is where it's extremely useful for all of us who are in the integrated warning team to make sure that we are talking off of the same sheet of music. This is where it's important that we're working together to make sure you guys on the media know what maps we're using in operations, so that way you're passing along the right message. And that's going to take some time to work through. How does this fit into our operations? How does this work in our coordination? But ultimately, the goal is we want to make sure consistent messaging when it comes to making these critical decisions for the general public. And that's going to be a topic we're going to talk about here in just a second. But I did want to point out one last thing, that you have to be careful with the bridges, because a lot of these approximated methods, the bridges are not going to be mapped. And basically your confidence is going to be tied to the quality of the map itself. All right, now for the fun part. This is probably where you're like, okay, this is what I've been waiting for. I've made it through all the tough material. This is the application of flood inundation maps. So how you use flood inundation maps will be up to you. And it's going to be up to your understanding of these maps and how they can fit into your operations and how much you can process in that time, or basically just the coordination with our office and what we can share with you. So likely you're going to start by looking at flood inundation maps tied to hydrographs, because that's ultimately like the bread and butter of what we're doing with riverine flooding. And then we might expand that service the more we use these maps in different events. We have to get rain though first. So when I talk about interpreting a flood inundation map, the first thing I want to make sure I'm conveying to emergency managers, media, general public, is start with the services we already provide. For example, the hydrograph. That is still important. The watches, the warnings, the advisories, those are still important. Don't neglect those products. Supplement with these inundation maps. Number 2, the map that you're looking at, does it look reasonable? Are there some really wacky output lines? Are there areas that you're like, oh no, that is definitely not going to be flooded, it's protected by a levee? You have to make sure that you know the map that you're looking at. You want to make sure that you're looking at a National Weather Service map or a vetted map from a trusted source. You don't want to be just looking at whatever map is handed to you when you're, walking on screen. Number 3, you want to locate key impacts. So when you look at flood and inundation maps, they can be quite overwhelming. You're not going to be able to pinpoint every single impact you see on this map. So you're going to have to be able to locate key impacts. So what do I mean by key impacts? I mean critical infrastructure. Where can we not access multiple subdivisions? Where do we not have access on major roadways? Do we not have access to schools or to fire stations or police stations? Those are the types of things that we want to pull out when we're talking about flood and inundation maps. And that's something that we're going to keep in mind when we're messaging impacts from our office. Number 4, neighborhood accuracy. it is going to be so hard to get people, especially in the general public, to not go to these maps and say, oh, look, my house is right on the edge of that flood extent map. I'm not flooded, I'm not going anywhere. And then just ignore what the local officials are telling them to do. We're going to see that, unfortunately, and we have to make sure we don't let that happen. We have to focus on neighborhood accuracy, not single home accuracy. We're just not that good yet. And number 5, we have to be careful of local structures. So that includes levees. If you know of an area that has a local levee that's not in the National Levee Dam database, then it's probably not going to show up here. One of the things we have to double check is if like the Cypress Creek levee or the Spring Creek levee are in here or not. Those would be 2 key areas that I would want that would trigger me to be careful in those locations because those are more localized than national. Now, if you look at the primary goal of using a flood and inundation map from an emergency manager standpoint, they're going to be looking at it first from a state level for strategic planning, so preparedness, enhancing resource placement, pre-positioning resources. Do they need to move resources from one portion of the state to another? Some counties might be strategically using maps in the pre-event timeframe as well, but they're going to be more so geared towards using these in an operational setting where it basically helps them to increase their readiness. Where do we need to be putting extra resources, a couple of hours in advance? And then, of course, we want to move into making decisions in the tactical time frame, but this is also the hardest time frame to use maps in because you're in that fight and flight mode. That's when you're doing evacuations and high water rescues. This is where it's really crucial that we are careful with using these maps. One of the reasons why we're careful with not sharing this out to 911 dispatchers is because this is just showing riverine flooding. If we are showing a map that certain areas are not inundated, we don't want to send people into those areas if there's flash flooding because you could then create a bigger problem than if you didn't have that map at all. So these are just some of the things that are going on in an emergency manager's mindset so that you're aware of that when it gets brought up into the big collaborative IWT perspective. Now, what you can expect from us. So with regards to impact-based decision support services, we can simply just make these services publicly available and say, that's good enough. We've provided a map to you. You can make your own decisions off of this, and you can ingest these maps into your own ArcGIS platforms, which you can. We have these services publicly available as REST services. But we have learned through various tabletop exercises with partners that that is not the best service we can provide. We can't just give you a map and say, go for it, because chances are you're going to make poor decisions if you don't know all the limitations or have somebody looking at these in more detail. Because let's face it, we barely even have time to look at all these inundation maps, much less everybody else who's got all these other jobs and tasks to do. So we are planning to implement FIM or flood inundation mapping impact-based decision support services in the platforms that we are already utilizing to coordinate the message with you guys. So what does that mean? Well, for example, our baseline IDSS is sending out graphics, sending out email packages, doing webinars. We're in NWS Chat 2.0. Those core platforms for conveying information to you is where we will start conveying information regarding flood and inundation maps. Now, we're not going to get super detailed in like an email to you all about all the different impacts that we're seeing on these inundation maps, but we're probably going to be pinpointing specific locations that we're paying attention to. Or we might be conveying saying, you know what, the GFS is completely out to lunch. Please disregard the National Water Model flood and inundation maps, but you can still look at the RFC flood and inundation maps. Those are the types of things that we would start with. Then as an event unfolds, we can start moving into a targeted IDSS, where if we know a certain basin or a certain area is getting hit, or is potentially under the gun, we can start targeting graphics, targeting emails and webinars to convey specific impacts that would help you in the messaging component or in decision-making component if you're an emergency manager. Now, what does that look like? Are we going to do basin specific webinars? Probably not. But this is where, we're going to need the IWT to help us convey what's working, what's not working, to make sure that you're getting the message that you need to convey that to the public. The last piece here is like the fully integrated IDSS, where let's say the National Weather Service deploys one of their forecasters to City of Houston or to Harris County EOC. Well, if they have these inundation mapping services embedded in their own ArcGIS online platforms, we can use their own overlays like reverse 911 or their own critical infrastructure layers and be able to tailor the briefings and the output to that specific partner's needs and thresholds. That's not going to be the norm. That's going to be a case by case basis. What is going to be the most common is this baseline IDSS where we communicate in our emails and our graphics and our briefings, or targeted IDSS where we're pushing out information specifically tied to an area to help with conveying more specific impacts. Now, one of the things that you might see, and this is what we would consider full decision support, is a graphic similar to this one, excuse me, where you would have the hydrograph on the bottom left-hand side. You would have the associated flood extent map that's zoomed into a specific location where we pinpoint locations where we have lower or higher confidence of the impacts actually occurring. It's time stamped because it's a dynamic flood extent map. It's got a disclaimer on the top that makes sure people understand that this is an approximate based flood inundation map or an efficient model based map, and it should be used more conservatively. Eventually, we would update this with the link. I think when we put this together, the link wasn't available yet. So this is just one example of what you might see. Another one might just be a simple blurb at the bottom of the email, kind of specifying, areas that we're watching or paying attention to. Now, what I want to do is I want to jump out of the presentation and I want to do a quick demo of where can you view these inundation maps. So the first one is on a national GIS viewer. So if you were to just, let me back out here. Let this load. Well, I was hoping that was going to take me to the home screen, but that's okay. So when you pull up this viewer, it's going to take you to basically the entire continental US. It's defaulted with the radar on top and the rainfall. But you can use the layers tab on the right-hand side. And there are many different options of what you can use. If you don't like the default, you clear it, not a problem. But if you were to scroll down, and it's underneath the radar products, it's this flood inundation maps FIM experimental. You'll see the word experimental because this is still an experimental product. And you'll see the three different options that we talked about. There's the latest analysis one, which is the analysis and a simulation FIM. So that's what's currently being flooded. There's the RFC 5-day max forecast FIM. And there's the National Water Model 5-day max forecast FIM. And it even has the GFS in parentheses behind it to remind you that it's based off of the GFS. So you can click on all three of these. Now we know that there's no flooding going on in Houston, so you shouldn't see anything. However, it's also, you're not seeing anything because of the zoom level that we're at. So you would actually have to zoom in order to start seeing something, which you shouldn't see anything anyway, so we're okay here. Now, the other thing I wanted to point out is this FIM coverage domain. And, oh, nope, sorry, not FIM coverage domain, FIM coastal exclusion zone. This is that coastal emission zone that I was telling you about, where you need to be careful with using the output because it's not considering additional assumptions based off of the terrain and the tidal influences and potential surge. Doesn't mean you can't use FIMs in those areas, you just need to be careful. And so that does cover a portion of the Houston area for sure. Now, I'm not gonna lie, you could zoom in here and there's probably gonna be a section down here below this nuclear plant that's showing flooding. This is what you would actually see if there was flooding going on. What's happening here is the threshold for flooding is set too low. And that's a nuance of the National Water Model Framework. So there are going to be issues like this. And I don't want you to freak out if you do see these in your area. Of course, we just need to make sure we control the message. We don't want people downstream, thinking their home's going to flood or anything like that. We are going to be very aware of locations like this so that we can help convey the message like there's no flooding going on here. But I just want to make sure you're aware that you might see some nuanced issues like this. And if you have questions about this, please certainly reach out to me. If you click on this location, it's going to have a pop-up and it's going to show you that it's showing 51 CFS. That's a toilet flush compared to what we deal with down here in Houston. So if you're seeing, low values, in the hundreds, that's nothing down here. Remember, one CFS is roughly one basketball passing underneath a bridge every second. So keep that in mind. It's all about perspective. The other thing I want to show, and there's many other options and layers that you can turn on here. If for some reason you're not seeing the inundation maps pop up, it could be that you're underneath a different viewer. There are different viewers. If you click underwater, there's different viewers that are experimental that allow you to see different products. So just make sure you're underneath the water one. The other demo I wanted to quickly show is the Informed Flood Decision Support Toolbox. So this is based from the USGS and Texas Water Development Board. And this is basically a repository of static, hydraulic, high quality flood inundation maps across Texas. And if you clicked on one of them, like for example, you would click on maybe the East Fork near Cleveland, you can see that there's a flood map library with all these different stages that you can click on. Let's say it's 25 feet. You would see this is one of those flood inundation maps that has depth. Again, you don't want to be tricked by the color curve, but if you were to actually click on the legend, it would show you that there is depth. The different colors represent the different layers. But of course, they are confined to the constraints here. One of the things that we are working on with the Inform group is to include the new National Water Center National Water Model Maps on this platform. So it's a one-stop shop. So you would have both high quality maps as well as the efficient modeling maps on this website. Now, they couldn't start work on this project on getting those maps into this platform until we turned on the services on October 1st. So we're giving them a grace period of getting that information on the platform. So maybe expect this to be updated within a month or two, and I'll certainly send an email when we get to that point. All right, we're almost done, so continue to bear with me here. All right, so remember I talked about that we're doing a phased rollout plan. The phased rollout plan basically means that we are not unleashing all of these maps to the entire country all at once. So we're starting off with the first 10% of the nation, and that's the areas in green here. So the areas in green are the first 10%. So we're the guinea pigs. We're the first ones right out of the gate. Our services got turned on October 1st. That means that we're relying on our feedback to make necessary enhancements to these services before we roll them out to the next 30%, 60%, and 100%. So the next area that we're going to be releasing these to in October of 2024 is the area colored in blue. So basically connecting the two areas in green through the central portion of the U.S. right here, basically the Mississippi Valley area, and the northwest portion of the U.S. Then 60% of the nation will be by October 2025, and that's pretty much the remainder of the Texas region. So if you have friends who work in the rest of the state of Texas that's not covered in the 10%, they would expect to get flood inundation mapping services by October 2025. And then the rest of the country is in teal, and those would be unleashed in October of 2026. And that's when we're expecting these to be transitioned from experimental to operational. So with that, I just wanted to kind of take a pause. I'm going to stop the recording